let's get into the big topic of open source, something that we actually say at Red Hat.
We haven't
This is so awesome.
are an open culture that
It's actually in a big piece
What is that process that a developer, or let's say
as the Kubernetes ecosystem really boomed?
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. I am Andrew Sullivan, joined as always by my lovely, talented, and amazing co-host, Mr. Jonny Rickard. How are you, sir?
Good. It's very nice of you to say those things. Thank you very much.
I mean it. I mean it from the bottom of my heart, Jonny.
I know. And it makes me feel good. So.
Well, good. I'm glad. So welcome to the audience. Appreciate everybody being here on this lovely Wednesday here in late May. I don't know about where y'all are at, but here in the Raleigh area, the weather is stunningly beautiful, and it's a nice day to be outside.
Awesome.
Working from Red Hat Tower today, so it's I'm only slightly the outside is only like 50 feet that way and down a few floors.
Nice.
Yeah, but so welcome everyone. Appreciate you joining us here today. So today's topic is something that I think is pretty interesting, and I have to admit that I'm going to be learning about this as we all go through. I know, Jonny, you've coordinated this, and Diego has graciously agreed to join us to talk about computer vision at the edge. And Diego, I'll ask you to introduce yourself, but also to kind of give us a little 30-second introduction to the topic.
Okay, so thanks for having me here today. So actually, this is not my first time on this show. I was here like a year ago talking about Microchip. So yeah, it's good to see that there's some interest on Microchip, and now that we are going to combine it with AI, so it's even better. So about myself, I'm Diego Alvarez, Technical Marketing Manager. I joined Red Hat like 2 years ago, more than 2 years ago. So I've been working on the Edge portfolio, helping users and customers to accelerate the Edge adoption and with resources and running some early access programs. And also recently I started some works on the AI ML spectrum. So that's when we came up with this idea of building like an entire blog series and video series about computer vision at the edge. So our idea here was just to move the data center and everything to the edge and run there all the computer vision models.
Yeah, and computer vision here is referring to like using a camera doing image analysis, or is that something different?
Yeah, no, that's exactly what we try to do. The thing is that we are emulating the camera input with a video file, but that was the idea, having a camera and detect animals there.
Awesome. Well, I remember your first stream when you and Henri were here to talk about Red Hat Device Edge. So using Rail for Edge with Microshift and showing just deploying applications and stuff like that. And it's something that certainly has not gone anywhere. I think since then, Microshift is GA now. I want to say it wasn't GA when you were all wrong.
No, it wasn't GA when we came here.
Yeah. So yeah, really great to have you back on. Always an interesting time. So we'll come back to that here in just a moment. So for our audience, please remember that this is an office hours live stream here on Red Hat Live Streaming. And what that means is that we are here to answer questions that you have about anything OpenShift related, whether or not it's related to today's topic. Effectively, what that means is Jonny is really smart and will happily jump in front of whatever bus of a question you happen to have. And if Jonny doesn't happen to know the answer, then we'll go back and we'll see if we can find out or ask the right people inside of Red Hat to get those answers. And usually what you'll see is usually it's me who's running my mouth while Jonny's typing furiously, because that's Jonny asking on Slack or asking one of the internal places if we can find a good answer. So
this is true.
Yeah. It's I tap dance. It's I have both marketing and manager in my title. It's what I do.
That's right.
So please don't hesitate to ask any questions that come up, anything at all that comes to mind. We'll do our best to answer those. If we don't have the answers, we'll find them. And if we can't get those before the stream ends, then we'll follow up next week and we'll talk about those. Let's see, what else what was I going to say? If you are not watching us live, I know a lot of folks watch us after the fact, then please don't hesitate to reach out. Jonny and I love to hear from you, whether it's on Slack or whether it's in email, wherever it is. Don't hesitate to reach out. We'll do our best to get back with you. And usually we'll bring up, or we try to bring up, or have a topic around whatever those questions are. So you can reach me, Sully, Sully, at redhat.com, or Jonny, Jonny, redhat.com. Which it is a coincidence that both of our email addresses line up like that.
That's right.
We did not plan that. So, wow, has it been since episode 62? Man,
Been a long time.
Time
What
flies
the
when
thing I
you're
remember
having
about that? That's exactly. Do you remember he had the awesome lab? Like he pulled his camera back and he had like the whole workshop, and it was pretty incredible. Yeah.
So with that, top of mind topics, Jonny.
I feel like I failed miserably here. There wasn't really a whole lot this week, so like I'm gonna have to punt it back to you because like I looked on the blog. It seems like it's pretty quiet right now. It's like I think we're in like a little bit of a post summit, kind of recovery
Hangover?
period. Yeah, I didn't want. Oh, yes, thank you. That's exactly what I was thinking. But yeah. So yeah, it's pretty quiet right now.
Yeah, there's been a bunch of stuff. The blog isn't necessarily quiet. It's just there's a bunch of stuff that I think we talked about when we did our little summit summary the other week,
Mhm.
and then it's other things that are sort of tangential. I think I will admit that one thing that I have not been able to keep up with is all of the commonly encountered problems, issues, and stuff like that. This is partly a result of me having to have been so heads down in summit stuff lately. But for example, I was chatting with one of our chief architects earlier today, and he's like, "Yeah, I was doing this thing with NM states, and I submitted in a network attachment definition, and it created everything, and it all looked great, but in fact, everything was broken." And so he was showing me like this whole process of how he got there, and then here's the RFE so that it goes in and does a bunch of validation for things that we had never even considered, just stuff like that. So if you're using network attachment definitions and NM state in order to create OVN bridge mappings, you can accidentally create those for networks that do not exist. So just be aware and make sure that you validate. And the way that you find that out is basically your bits go into the ether. They go, or your packets, I should say. There's like no error messages. It just silently creates it, and it doesn't do anything.
Oof.
But, yeah. I also saw that I think we're getting close to the Kubernetes 1.30 release. I thought I saw it somewhere. I don't think it's been released yet, but it feels like it's about time for one of those to happen. You were talking about the code name used for the most recent one for 1.29. I don't remember if you get up and...
Let me find it. Oh, it's actually, yes, I found it. Kubernetes. So let me. So it's awesome. That's the release name. It's amazing.
Nice.
And it's got like this I don't know, like a Pikachu. Is that what it is? Like the I don't know what the cartoon is called. Wow, I'm totally old right now.
You're asking, do you see how much gray there is in my beard? Like you're asking.
Oh man. Pikachu, what is it? I really have no idea. That's terrible. Like I can't remember. I remember the main character's Pikachu, so it's got like that vibe, right? Like that. Yeah, it's something.
I don't think it's a furry. Anyways, so we'll quit tap dancing around the subject and more or less just keep your eyes on the hybrid cloud blog on redhat.com. There's a number of other things that are coming out as well. For example, one of the folks on my team is getting ready to publish a solution pattern. We're doing some stuff with machine learning and that type of stuff. So lots of exciting things that are coming up, and we'll be talking about those throughout the summer. Wow, it's already almost summer. I realized that the other day, Jonny. You realize that the summer solstice is in like a month?
No, it hit me this morning that Memorial Day is next weekend. I was like, holy crap.
Yeah. Yeah, well, not even next weekend. It's this weekend. It's Monday.
This weekend. Yeah, exactly.
Yeah. So I know that doesn't mean anything to folks outside the U.S., but for us, it means we have a 3-day weekend. Yeah. So let's talk about device edge. Let's talk about, well, edge deployments in general and computer vision. And Diego, this is something that's, I admit that I have had a passing interest in for a very long time. And I say that because a long time ago, like 7-8 years ago, I was working on a project when I worked at my previous company where we were actually using Raspberry Pis and capturing images and then sending them into basically an object store, an NFS store, and then doing post-analysis on that. And so I worked for a storage company, and it was just a really cool project that we had. I distinctly remember being up very late one night and recording pictures of myself from across the room. So it's like pictures of the back of my head that we were doing. Anyways, so this type of use case was always something that was kind of interesting to me as being one of those that it feels very, I don't want to say attainable or achievable, but it kind of is. And I'll reinforce that by saying, Jonny, I know you've worked on a couple of validated patterns that are doing something similar. The medical imaging diagnosis one, and I think there's another one.
Right now, it's just a medical one. We are working on some other ones, but we've worked with the data science team over in NAPS, and they were doing some stuff with drones, and yeah, they were actually using computer vision models and stuff like that, or images from like a repo, pulling it all in and doing stuff with it. So yeah, it's a pretty awesome thing.
Yeah. So this is it's interesting, and I'm always curious to see like the new iterations and what all this looks like. So I'll stop stealing your spotlight here and hand it over to you. Bruce.
Yeah, no worries. Thank you so much. So yeah, I hope everyone can see my screen right now. So basically, what you are watching here is the GitHub repository where we have all the components, the notebook, the images for the dataset, and all the needed resources for this to run this demo. So actually, thanks for bringing the topic about drones, because what we wanted to do here was to show the entire process of building AI models, but also we wanted to move the typical data center closer to the edge, because, well, basically, maybe you are asking why we want to move that to the edge, because, well, basically what you would like to have is a big server with lots of resources like GPUs, memory, a full cluster. But there are some specific use cases that could be interesting at the edge. So talking about drones, for example, you can imagine having some kind of platform at the edge with a fleet of different drones that are taking pictures, for example, but then they came back to this edge platform. And we want those images to retrain the model so it can be modified to keep detecting other new objects. So that's one of the reasons why we wanted to move the data center closer to the edge, because usually there are some scenarios where you don't have like connectivity, or you cannot send those images back to a big data center. So having a data center here was something that we wanted to explore. But also keep in mind that when we have something closer to the edge, that could mean that we have fewer or not so many resources available. So that's why we decided to go with a lightweight version of OpenShift, and that's single node OpenShift. So yeah, talking about this repository, here you can find all the blog posts. Those are uploaded to the Red Hat developer blog page. So here you will find all the steps needed to build the infrastructure and to run the demo by yourself. So before starting, in this demo, there are a lot of different moving parts. So I would like to use some of my time to talk about this diagram. So as you can see here, we have two different different environments. So the first one is going to be the data center. In this demo, we are going to show you how to run this on a bare metal server at the edge. But also we wanted to include the cloud here just to show that you can also train your models on single node on the cloud. But yeah, what I will show you today how to do it on bare metals. In my case, my node has a GPU, which is going to be interesting to have because we want to accelerate the training later. So yeah, that's the idea. We are going to have this server. We are going to deploy a single node on top of it. I already did that before the live stream just to speed up the process. And then we are going to use this server to train the model. And so for this, we will need Red Hat OpenShift AI. But also Red Hat OpenShift AI has some underlying requirements, like having some persistent storage, and also we will need to expose the GPU so it can be detected and use it during the training. So we are going to install all these operators, and when we have this platform ready, we are going to deploy a notebook where we are going to use YOLO, which is a computer vision model. We are going to import a dataset with the images for the different animals that we want to detect here. And we are going to train the model using the GPU. And once we have it ready and validated, what we are going to do is embedding this model into a container image so it can be later pulled from the edge. So that's all we have on the left side.
And Diego, I want to
yeah.
interrupt you here for a moment because, so for anybody who is watching like the Red Hat Summit keynotes, right, we made a bunch of AI related announcements, right? There was the Granite models, which are LLM based models. They're not image analysis models. Right? So there's one for doing like, I'll say, I'm trying to think of the right word to describe it, but basically, having a chatbot or a chat-like interaction with the LLM, and then there's another one for code generation. But there is none of those, at least as far as I know, I remember it being announced, anything for doing like image analysis. So in this instance, we're not using one of those Granite models for doing this. This is one that's being built as a part of the demo. And then additionally, I don't think InstructLab plays a role here either, because I don't think InstructLab works with images.
So I'm not sure if we could use InstructLab here for this purpose. But yeah, I haven't tried. I'm not sure. I think no, it's only for LLMs, but I'm not sure.
Yeah, and so for anybody, so if you're not familiar, so InstructLab was also announced at Red Hat Summit, and it gives anybody the ability to go in and in a friendly manner, basically you train the model or you teach the model some sort of knowledge. So, is Jonny living in Texas? Yes. Is Jonny working for Red Hat? Yes. Does Andrew live in Texas? No, right? Type of thing. And you provide it with these, knowledge effectively, and you teach it a skill that it uses to augment the underlying model with. And it does this using, and now I forget what the lab part of it stands for, but basically it uses another model to generate synthetic data based off of those inputs that were created by a human. So I create 10 pieces of data, it creates 10,000 that are then used to refine the model with a greater degree of accuracy. Again, I believe that only works with LLMs and text-based type of input, as opposed to what we're doing here, which is image-based. So still relevant, still important, just not necessarily in this particular context. I hope for anybody who's AI savvy watching this, I did not completely butcher that just now.
Okay, so yeah, now we are going to continue with the right side. So once we have this container file with the model embedded, we are going to push it into a repository in Quiet, for example, so it can be pulled later from the edge device. So in my case, the edge device is going to be emulated using a virtual machine. So we have a Red Hat Enterprise Linux operating system there. We install Microchip on top of it, and then we are going to use that Kubernetes platform at the edge to deploy the application and access the application from that device at the edge. So I hope it's clear. So right now we are going to focus on the left side to set up the data center, and then we can go back to this picture in case we are a little bit lost here. So if you don't have anything else, we can proceed with the hands-on demo, if you like.
Yeah, please do.
Okay, so I have here my single node OpenShift. So to deploy this single node, I use the assistant installer. So everything is documented on this blog post. But I would like to show you what I did before. So the first step is to go to the Red Hat Hybrid Cloud console. And here we can use the assisted installer tool to simplify the deployment of the clusters and single node in this case. So we go to OpenShift. And if you go to the cluster section here, you should be able to create any cluster you would like. So let me show you how to do it really quickly. So in my case, I'm not using the cloud. I'm using a bare metal server. So I will go to the data center tab and click on create cluster. And this is the template you need to like fill in to simplify the deployment. So I'm going to write name for this single node. I'm going to write a base domain. So mlab. So yeah, this base domain needs to match your environment. Here you can select the OpenShift version, the CPU architecture. In my case, I'm using an Intel bare metal server, so x86. And here comes the important part. You need to check this install single node box. And that's it, because later the storage and the network configuration will be detected automatically. So in the next page, we can see some operators that can be automatically deployed for us during the installation. But in this demo, what I did was skip this part, as we are going to install some of them, like LVMS, later manually. And now we have this node, and we need to connect this node to the assistant installer. So to do this, we are going to create a discovery ISO. So we are going to use this ISO during the boot process in the node. So it can install all the dependencies and requirements. So it can be detected from this assistant installer tool automatically. So all you need to do here is select the image file, also paste an SSH public key and generate the ISO. And you can download here this discovery ISO. So finally, as I told you, what you need to do is go to your node. In my case, I'm managing my node by using an iDrive. So let me log in here. So this is the iDrive I'm using to manage the node. And basically what you need to do is setting up this node to boot using this discovery ISO. In my case, I'm connecting the virtual media here. And I'm going to choose the file we just downloaded. I'm going to map the device. And finally, select the boot controls. In my case, we need to select virtual CD, DVD, ISO. So once we turn on the node again, it will use that image to boot up and will install all the dependencies. And at some point, the node will appear in the assistant installer. So we are back here. The node will appear here. Then all you need to do is click next, as the storage is going to be detected by default. The networking also is going to be detected. So when you click next, you can start the single node installation itself. And when you complete this process, you will have something like what I have here, this single node, which is the one I just showed you. And you will get the console URL, the kubeadmin, and the password. So you can log in and start playing with this single node, which is where we are right now. So that's all I did before the live stream. So now we can focus on the deployment of operators and so on.
Thank you, Diego. And I'm going to interrupt you here because I want to answer Christian's question real quick.
Yep.
So what's the difference between OpenShift and OpenShift AI? And what I want to point out is they are both OpenShift. So OpenShift AI, and what I put in the chat here is it is a collection of tools and applications that assist with data scientists with creating, building, training models, as well as a set of tools to do things like ML ops. So being able to serve those models, to control access, do all of those other things. But it's more or less deployed as an application on top of OpenShift. So the underlying OpenShift is exactly the same. And what we're starting to see is additional things inside of the Red Hat portfolio that are using OpenShift as a platform for them to deploy and scale and et cetera, in the same way that OpenShift itself is a platform built on top of RHEL. So you could argue in some ways like Ansible automation platform is that way, at least in one of its deployment models, right? I'm deploying OpenShift and then I'm deploying Ansible on top of that. The Developer Hub stuff, same thing, right? When I deploy Developer Hub, it's a platform that is deployed on top of. So, yep, OpenShift prepack for data science and ML ops. I will say it is not necessarily an OpenShift that is pre-configured. You would go in and, just like Diego just showed, he just deployed a regular OpenShift cluster for all intents and purposes. It just so happens that the hardware he's using has resources, GPUs, that are important and not really specific, but important for doing data science and machine learning and stuff like that. But aside from that, there's nothing special about the underlying OpenShift. It's the things that are on top of it, and OpenShift AI goes in and deploys all of its helpers, all of the things that make it easy for me to now go in and create my
Data science projects.
What do we create workbooks in that I cannot think of the name of right now? PyTorch? No.
Notebooks. You're talking about like the Jupyter Hub, like Jupyter notebooks?
Jupyter Hub. Thank you. I don't know why I cannot remember Jupyter Hub for the life of me. I need to put it on the whiteboard over here or something. I can never remember Jupyter Hub. But yeah, so it pre-deploys all of the things that you need for that, or I shouldn't say pre-deploys. It makes available, and it gives you this nice interface for going in and saying, oh, Andrew is a new data scientist or a data scientist who wants to create a new project. I need access to X CPU and memory and Y GPU, and I want to create it using Jupyter Hub and blah, blah, blah. And I go in and I train my model using those resources. And okay, now I'm going to store my model somewhere. Now I'm going to serve my model using something. It provides all of those different tools just out of the box as a pre-integrated and tested set of resources that you can use for doing either the data scientist model building piece or the ML ops, machine learning operations. I think that's what that stands for, right? Side of things.
Yeah, no, we are going to see this on detail later. So we'll explain how to install the platform and how to create all the notebooks there and to serve the model.
Yeah, go ahead, Diego.
Yeah, so let's continue by installing the operators that are required for OpenShift AI. So the first one we talked about was LVM storage. So this will provide some storage to the node and to the notebooks. So all we need to do here is click on install. So as you will see, it's quite easy to install all the operators. We don't need to modify any of the parameters. Basically here, maybe you're asking why we are using LVM storage instead of Red Hat OpenShift Data Foundation, for example. So LVM storage is the approach we have when we are talking about single node at the edge. So this will provide dynamic storage in our node. So actually something that we can do in the meantime is also log into this cluster. From the terminal, as we can also track from the terminal the deployment of all the operators. Okay, so we are here, and if I run OC get nodes, we should see that we just have one node with master and worker capabilities at the same time. So let's go back to the web console. the operator is installed, but we need to create the LVM cluster custom resource. So this is what we call the operand. Here we need to select this storage class that is going to be deployed in this node as the default one. So later, if there is a PVC, for example, that we need to create, it will try to look up for a storage class by default. So once we have this configured, we will not have any problem. So as you can see, it's ready. If we go to storage, you can see that the default storage class was created. So yeah, that's it. Now we have some storage. So the next step will be exposing the hardware, in this case, the GPU. And for this, we will need the node feature discovery operator. So again, click on install and install again. So this operator, what it's going to do is going to look up for the hardware, the GPU, for example, and it's going to label the node where the GPU is present with a new label. So it can be used later from the NVIDIA GPU operator, for example. So in my case, we just have one node, so that's the only one that is going to be labeled. And I will show you in a couple of seconds how the label looks like, because it's going to complete the label with the PCI number or the PCI ID for the vendor. In my case, I have an NVIDIA card, so the PCI will be 10D. But yeah, I will show you this in a second. We're going to create the node feature discovery instance here, and also we can see that it's available. So let's take a look to this this label. If we go to compute nodes, this is my node, and if we go to the details page, we can look for the PCI 10D. Yeah, as you can see, this operator has created this new label, so it can be detected. The GPU can be detected by the NVIDIA GPU operator. So that's it. And the last step will be installing the NVIDIA GPU operator.
It's so much better now. Like, this used to be such a pain. Like, I'm the NFG operator is awesome. So like, I'm excited that this thing is actually out here and, you know, already doing awesome things.
Yeah, exactly, because you don't need to worry about how to manage and how to make this GPU being efficient. So it's already managed by this operator, and it's fantastic. So yeah, next step will be creating the cluster policy. As you can see here, we have a lot of different values that we can configure, but the default ones will work for us. So create. And also let's track the progress. So the project is NVIDIA GPU operator. So if I run watch OC git post in the namespace NVIDIA, yeah, we can see here that some pods are terminating, some others are initializing right now. And at some point, we will see all of them running. But this operator will take a couple of minutes to finish the deployment. So what I usually do in the meantime is configuring the image registry, because, well, basically, there's something that we need to understand here. When we deploy single node OpenShift on platforms that do not provide shareable storage, the image registry bootstraps itself as removed, so the installation can finish. And the user is who needs to re-enable this image registry in case if needed. So that's what we are going to do here. We can access the image registry from the cluster setting, cluster operators. Here we are going to search the image registry. And here in related objects, we can see the cluster configuration. If we go to the YAML, you can see here that the management state is removed and also the storage is empty. So we are going to change that so we can start using this image registry. So the first thing is change this value to manage. And also we are going to create a PVC for these images here. So we need to add those lines, storage, PVC, claim. And important here, I'm going to keep this value empty as it's going to be created by default. So if everything is correct, we can save the changes and reload the object. Oops, sorry. And here we should see exactly the management state is managed and the claim has been filled automatically. So we can take a look to this PVC from the storage section. So here it is, but as you can see, it's pending, and I will show you why. If we go to the events, we can see here that the access mode is unsupported. This is because the PVC was created in read-write-many access mode. So we need to use read-write only for the LVMS storage. So it's easy. What we are going to do is just deleting this PVC and creating a new one. So first of all, I'm going to copy this name because that's the one we need according to the YAML we saw before. And we are going to go to the OpenShift.
I want to interject for a moment and point out that maybe because you're logged in as your regular user and not an admin user.
Yeah, I'm an admin user too.
So the LVMS operator, so logical volume management. So effectively what that operator does is it takes local storage resources and it carves them up for use by pods using LVM. So the reason why this PVC is invalid is because it requests RWX, and of course using local storage you can't use multi-access or multi-host access storage. Also a single node OpenShift, so you're only going to have a single node anyways, but it's neither here nor there in that instance.
Okay, so we are back, and now we can see all the namespaces. So there was a problem with the connection. So as I said, we are going to copy this image registry storage name, and we are going to go to the OpenShift image registry. So we are going to delete this PVC and create a new one. So here you can see the storage class is detected automatically, and we are going to, oops. So image registry storage. I think this was the name for the PVC, but we are lucky that we have the blog post here, so we can take a look if that's correct. So yeah, here you can see all the steps. Image registry storage. Yeah, I was right. So we are going to assign like 30 gigabytes and create this one. And as you can see, now it's bound. So the image registry is configured. Let's see how this goes. And well, also it's ready, the NVIDIA GPU operator. So I think we have everything prepared to start deploying OpenShift AI. So
I can't help but wonder if there's a way at the operator level to change that PVC type. But that's
yeah, I tried modifying the YAML, but I couldn't. That's why I was recreating it manually. But maybe there is a way to change that specific value there. So here we need to find the OpenShift AI operator. So yeah, we were talking about this. It's deployed like an operator, so there's not really any different from OpenShift. We are deploying this platform on top of it and taking advantages of all the perks of OpenShift here. So yeah, we are going to use this platform to create the notebook. In my case, we are not going to create it. We are going to import an existing one, and then we are going to train the model. So yeah, the beauty of this is that basically the infrastructure is the same for all the, let's say, models that you want to train. So all you need to do is changing the data set and the training, and that's all, because the infrastructure is going to be the same for all of them. So yeah, let's create the data science cluster. And we should be able to access the platform in a couple of minutes. So yeah, just as a summary, let me show you where we are. So we have a single node on top of the bare metal server. We install these operators and we just deployed OpenShift AI. So now we are going to import the dataset once we have it ready. So sometimes it shows ready, but you need to wait a couple of seconds. Yeah, exactly. So it finishes deploying all the components.
So Diego, real quick, one thing just to note on like the OpenShift AI operator, like this operator, right? It's a I'm going to use Andrew's word here, right? It's a fractal, because like as soon as you click on OpenShift AI, then you can do service mesh, then you can do Knative serving, then you can do OpenShift pipelines. Like it's basically like it's a gateway. It's a gateway operator, right?
Yeah.
Like it enables all these other services where you can actually do some really dynamic and advanced, model serving and stuff like that within the platform, right? And pretty much anywhere, just like you were saying, like it goes anywhere, and you can enable all these features and stuff like that. And then the last thing, did you get your YOLO stuff from Kaggle?
Yeah, I got the dataset from Kaggle, but also we have a separate blog post to let you know how to train a custom model. So if you want to train something, the problem is that we will not have enough time to take a look. But yeah, so everything
that'd be an all-day stream, right?
Yeah.
So just for the audience, I'm sorry, and I'll shut up after this. Just for the audience, if you wanted like pre-trained models, there's some stuff out there. The link is kaggle.com, I think, but I'll share it with you. And yeah, it's just like instead of you having to bring your own model, like they've got pre-trained models, they've got data sets that you can use. Like they've got all kinds of like pretty crazy things that you can use just to basically get started. That's it, Diego. I'm sorry, I'll shut up.
Yeah, no worries. So yeah, this is the Red Hat OpenShift AI dashboard. So what we need to do here is creating a project. So we will call it Safari. We haven't talked about the application, but I will do it in a couple of seconds. And the next thing will be creating a workbench. This is where we are going to deploy this data set, the model and everything. So I will call it Safari 2. Here we can select the notebook image. So for example, in my case, I will use PyTorch, but you can use others depending on the requirements of the model. And even you can create your own images here. So yeah, that's nice. Here we can select the deployment size. Medium works quite well for our model. And here comes the important part. If you see here a GPU, is because you did all the steps before correctly. So as you can see, the NVIDIA GPU is being detected. And also I lied a little bit because I have two GPUs indeed in this server. So you can select the number of accelerators you want to speed up the training. And that's it. We are going to create a storage. I will increase the storage size because, well, we are going to import the entire data set. So I have plenty of space in this server. And that's it. We create the workbench. We can track the process from this page. And this is why we have to enable the image registry, because if we take a look to this image, we are getting the PyTorch image from the image registry. And that's the reason why we had to enable it before. So as you can see, it's quite simple and quick. So now we can access to this Jupyter environment. Okay, let's wait a couple of seconds. We will see something here. Okay, so here we are. Here we have the option to deploy and create a notebook. But what we are going to do is importing all these folders and the dataset from a Git repository. So I'm copying this URL here, and all we need to do is pasting it here, and it will start cloning the repository. So it will take some time because we have all the images there. So what we can do in the meantime is talk a little bit about the dataset that we are going to use. So first of all, the application we wanted to build is like we wanted to emulate like a device that is detecting animals in a Safari, for example, and is giving you some information about the animal you are seeing from the camera. So to do so, we have to train the model using some animals images. So here we have all the images. As you can see, we have, for example, a bear here. Yeah, I don't know why this bear is drinking something. I didn't take this picture. But the model, what it's going to try to do is look up for the same name as the image has in the label folder. So it recognizes where the animal is in the image. So if I go to the labels, we have here this exactly same name, but in this text file, we are specifying the animal and where the bounding box are. So basically, the number 22 is the beer. So instead of using the animal's name, we are codifying it with some numbers. And the next value will be the x coordinate. So the coordinate on the x axis. The next one, the coordinate in the y axis, and then the width and the height of these bounding boxes around the animal. So yeah, and that's all the model needs to detect and to know where the animals are. But if you want something more visible, let me show you an example here.
And just to kind of complete that, so what you're showing is essentially you're providing the notebook an image. In this case, it's an image of a bear, and then you're telling it in this box is a bear.
Exactly.
And we feed it, a bunch of different images that all have a bear, and we tell it where in that image the bear is, and it learns from that conglomeration of things what a bear looks like, and therefore can make an educated guess in the future about it. So this is where the data scientist comes into play of like, I have to be able to, classify, taxonomize, and describe the data that I'm looking for to the model. So that way, when I train the model, it doesn't just, if we were to look at that whole image and say, oh, this whole image is a bear, there's a lot of other things in there, right? Sidewalk and background and maybe the handler's leg or something like that. None of that is a bear.
Yeah, exactly. And this is the typical example. As you can see, this is the image, and we are telling the model, well, we are creating a different line for each object. In our case, we just have one beer on the image, so we have just one line. But the first value is the class. In this case, for example, 0 means a person. So it means that we have a person. The center of the box is in this position, which is this one, and this is the width and the height of the bounding box. So we need to do this with all the objects, and that's why this is important to have like a good tool to label all the data set, because this is usually the step that takes the most time. So yeah, well, sometimes you can see here an error message, but it is because the repository is too big. So we should see here all the folders that we saw on the GitHub repository. So we have the notebook here. The one that we are going to use to train the model is this one. So here what we need to do is start running all these cells. So in the first one, we are going to import the model, and YOLO model is coming from Ultralytics. And we need to import and install other Python dependencies. So what we need to do is run this cell here. And later, what we are going to do is making sure that we have the data set that I just showed you. So yeah, as you can see, we have the test, the train, and folders, and both folders for images and the labels. So of course, I'm not going to train the model here. It's a bit big model, so it took like 30 minutes to train each iteration. So this is something that I did, and for those who don't want to use their time to train the model, we already provided some weights files so it can be followed without waiting so much. So yeah, next step will be checking this data set, as I told you, and the next one will be to train the model. So that's how easy it is. So all you need to do is specify where the data set is. So I will show you how this data YAML file looks like. You can find it in the dataset data. So here we are telling the model where the train images are, the validation images, the number of classes, and the names for the classes that we have. So for example, you remember that we have 22. So that means that in the position 22, we should have a beer at some point. Yeah, here it is. So all of them are in order, and this is where the model understands what's the name and the correlation with the number we assign. Okay, so that's it. I'm not going to run this cell, of course, but I want to show you that we are using the GPU here, so it's going faster. Here we're doing all the training, and when it finishes, we will get a weights file basically containing all the information for the model to understand what an animal is, where they are. So we are going to use this weights file to validate the model. So if we go to the next cell, we are going to load this weights file to the model, and we are going to use a sample image to test and validate how it works. So important here, you cannot use the same images you use for the training to validate the model, of course, because, well, the model already knows where the animal is as it has seen the image and the label before. So this is a completely new image, and as you can see, with only 20 iterations, it works quite well. So it's detecting a brown beer with 94% of accuracy. So we know that the model is working. So the last step is to export this model so we can embed it later to the container image. So that's what we did here. It's going to create a weights file, a best ONNX file. And that's the one we are going to download and embed into the application. So that's all we need for the training, and we can continue with the application creation if you like.
Yeah, in that OMX file, that is the model. So going back to what we were talking about earlier about OpenShift AI, so we just used OpenShift AI as the platform to train the model. There are other features that we're not going to be using here to serve that model out.
Yeah.
And so, for example, model serving OpenVINO, for example, right, would basically act as an API endpoint where maybe this is running inside of a data center, right, the application and OpenShift AI. So now somebody submits a picture into my application, the application sends that picture over to OpenShift AI hosting the model, and it does the analysis and then spits back the result. In this instance, because everything's running at the edge, we don't want to have to send, hundreds, thousands, millions of images back to something that's on the other end of a wire, that's a different data center, maybe limited bandwidth, latency, all those other things. We want it to do all of that analysis locally. So that's kind of where or how all of this fits together.
Yeah, exactly. And also we are thinking about adding some new chapters to this blog series, also showing how to serve models from OpenShift AI. So yeah, stay tuned because that chapter will come at some point. So let's talk about building the image. Is there anything you wanted to mention, Sully?
Nope. Just that I know most of the time when we show these things, we don't often show like an image type of a model, an image analysis type of model being at the other end of an API because, they're heavy to move around. It's typically things like a little bit of JSON text or something like that that gets sent over and some analysis done on it. that type of stuff. Just efficiency things, not because you can't, just because it doesn't always make sense.
Okay, so now we have this application folder where we are going to store all the resources needed to build the image. And here is where we are going to copy and paste this ONNX file that we obtained in the static folder. So I will show you how this code looks like really quickly. First of all, we need a container file. We are using a UBI9 plus Python base image. We are creating a work directory, and apart from some Python dependencies, we are going to copy all the contents from this app folder inside this work directory. And then we are going to run the API script. So what we have here is quite simple, just a Flash server that is going to serve the model so we can access it later from our web browser. And it's going to render this template, the index HTML. So let's take a look at it. Here is where we have all the logics for the graphical part of the application. So all the stats will be complete here. We are going to give some format to the play, pause, button, etc. And also we need to specify here the input images. As I told you, we are using a video file, but in that case, if you are running this on an edge device, real edge device, you can use input from a camera, for example. So that's the video, and we are going to also specify the object detector, which is where basically the magic happens. So here is where we have our model. We are getting the video frames from the video we saw before. We are also creating a worker because we don't want to overload this thread. So we create a separate one where the detection will be happening. So when this runs, we are going to, when you press the play button, we are going to send the picture to the worker. And here we are going to do all the detection. And as you can see, here is where we specify the model we just trained. So it should be able to detect the animals, and it's going to send back all the information to the object detector. And then we can use here the labels and the detection to do whatever we want. So in our case, I'm getting the label that is being detected, and I'm looking for some information in a stats CSV file that I created. I'm going to find this animal, I'm going to split the line, and I'm going to complete these values that we want to show later on the graphical part. So that's the idea of the application, and all we need to do is use Podman to build this container file. So I can do it here. Podman build, I'm going to tag this image to match my Quay repository. Safari, latest, and we are going to specify this folder. And we are going to build the image here. So probably it will fail, or maybe we are not going to push it because I already have it on my Quay repository. So yeah, let me show you my Quay repository. So all you need to do right now is just Podman push the image, and you will have it here in your Quay repository. So that's the image, and now it's stored on our repository, so we can access it later from the edge. So that's it. That's all we need from the data center side of the demo. So we have complete all the steps. We have the image, so we can now jump to the edge device. As I told you, I have a virtual machine here just to emulate the device. And also I have deployed Microchip before. So let me log in into the virtual machine. This is my virtual machine with RHEL 9.3, which is the latest version supported for Microchip for the 15. And also I will show you Microchip running here. So system, CTL, status Microchip. There you have it. It's running, and also we can see the pods. OC get pods. So those are the pods that Microchip is deploying. So I was thinking about showing how to install a microchip, but it's really easy. So all you need to do is following the official documentation, and in just 10 minutes, you will have your microchip deployed here. So, but yeah, let's take a look at it really quickly. Okay, so here you have all the requirements. The first thing is to enable the repositories where microchip is. And once they are enabled, we can install microchip packages from it. And the next step will be to get the pull secret from the Hybrid Cloud Console. So if you go to the Hybrid Cloud Console, the one that we used before to use the Async installer, for example, there is a section on the left side for the downloads, and we can get the pull secret from it. Let me show you where it is. Yeah, that's the section we are looking for. I mean, I guess you have already done this before, but it's always good to remember where those things are. But yeah, here you have the pull secret and you can download it from here. Yeah. So once we have the pull secret, we are going to move it to the etc CRIO folder. We are going to give it the right permissions for the root user, and we need to enable some firewall zones so microchip can run. And then we can jump to starting the service. So just to mention that we also have the operator lifecycle manager that it was included recently. Also, we can do some GitOps and CAD operations from microchip too. So all of them are optional features that you can enable. And finally, you just need to start the microchip service, which is the one that I showed you, and create the cube folder, export the cube config to that folder, and give the right permissions so you can access the node as I showed you. So that's it. That's all you need to have microchip running. So the last step will be just to deploy the application. So for this, I'm going to open this deployment YAML file. And as you can see, it's quite simple. All you have is the name. We are exposing this port, and we are going to specify in the image the one that we just created and pushed into Quay. So that's it. That's the deployment. So if I run OC deploy from file deployment YAML, I'll typo here.
OC create.
OC create, yeah, exactly. I've been talking for too long. OC create. Okay, now we can see that deployment is created. We can expose and create a service. OC expose deployment Safari. So we created a service. OC service. We have here and the IP, and we are going to also create a route to access the application. OC expose service Safari. Okay, if I run OC get route, this is the route to our application. So before opening it in the web browser, I will add this entry to the DNS so it can be linked properly. So sudo and I'm going to add the new entry here. So the cluster IP will be 10.43.199.158, and the URL Safari default apps example.com. So that's it. if there are no any typos, we should be able to access the application. So all we need to do is open the web browser, and so yeah, maybe there was a typo or something there.
Look at your port.
Sorry?
Was that port correct? The 5000?
Yeah,
right. Okay.
yeah, that's the port.
Okay.
Yes, has to do something with these. Let me see if I wrote the sudo ptc. And I will do new terminal. (43.199.158). That's the problem. The fault. I think that was the problem. Let's see if we can access. Yeah, here we have our application. So this is the graphical part, and we can start playing with it a little bit. So at this point, the model is starting, and this is the video input we are using. So here I'm sharing my screen. The connection is not the best, so probably it will not look like a video. But if you give the enough resources to the virtual machine, or if you specifically have a device at the edge with enough resources, this will go faster, and you will be able to detect animal here. So yeah, that's all I wanted to show you today. I hope it was easy to follow. At least we have all the blog posts here to guide you through all the steps.
This has been great, Diego. I really appreciate that you walked through the end-to-end and showed where each component fits together. And I think, coming out of Summit, where we talked a lot about AI, when I talked with people, on the expo floor, in the hallways, before and after sessions and labs and all that other stuff, there was a lot of, I don't know that everyone is able to piece together like where everything fits. Like, let's ignore the, do I even need AI or machine learning or anything like that? It's the, how do all of these things fit together? What does it look like? And I feel like this is a great end-to-end example of OpenShift AI or OpenShift AI, and then Device Edge and Microshift all fitting together to create a cohesive story. And I don't know, it's amazing to me. It's really great. And thank you for putting all of the work into this and showing all of these bits and pieces.
Yeah, thanks you for having me here.
So to the audience, and I know Jonny and Diego, you did a phenomenal job with this. So Jonny and I didn't have a lot of questions or anything because it's very logical, and at least to me it was. And I'm a professional dumb guy. Remember, manager, marketing in my title. So for the audience, please don't hesitate to ask any questions that you happen to have. I feel like we are happy to do our best to answer those. I know we've got some other AI-centric things that are coming up. We've been talking about OpenShift Lightspeed and trying to get some of those folks on as well, right, Jonny?
Yeah.
I think we're just trying to coordinate calendars. I keep hoping. I kept saying leading up into Summit that, oh yeah, after Summit things will calm down. My calendar will be a little more clear. No, that has not been the case.
No.
So, yeah, please don't hesitate to speak up if you have any questions. If you're not watching us live, please feel free to reach out. So you can always contact myself via email, xully@redhat.com, or Jonny, Jonny, @redhat.com. We're also on the Kubernetes Slack. I feel like I always toss that out randomly, Jonny, just to watch you like scramble to find the. So, yeah, so the link there goes to the OpenShift users Kubernetes Slack channel, and I always remind folks that if you, so like all Slack channels, it requires an invite to join if you're outside of the organization. If you go to slack.kubernetes.io, there's a whole thing to invite. Slack.kubernetes.io. I should be careful there. Kubernetes.io. Did I misspell it? I didn't misspell it. See, Diego, you're not the only one who makes typos. Mine just are off screen. Yep. So if you go to slack.kubernetes.io, it takes you to the invite generator. So you just plug your email in there, and it'll send you that invite. And then just look for that. You can just go into the channels and search for OpenShift users, and you'll find not just Jonny and I, but like 3,000 or 4,000 of our closest friends as well. So
Yeah.
yeah,
Now we've got one specifically for it, so that way we're not doing OpenShift users every time.
nice. It's almost like we've been doing this, for the last 4 years, and we're almost getting good at it.
We're learning.
All right, Jonny, do we have a topic for next week yet?
I don't think so. I'm just clicking on everything now. No, I don't think so. Not yet. I think I'm going to talk to some folks tomorrow morning, and so it's possible that we by tomorrow mid morning we'll have something lined up. It's just we're kind of in like this I don't know what the right word is, like weird state where we're trying to confirm with a bunch of different people at the same time to get everything lined up and just.
Yeah.
I think the hangover is probably the best word, right? Like we're just trying to get everybody to get back in the mode of getting back into speaking after this.
Well, it didn't help during our hiatus that you were completely out and disconnected, and I was still here, but mostly disconnected, and so we were just kind of randomly, as one of us would pop in, we were like, yeah, that's it. We should do that topic, and like, oh look, this day sounds good, and in fact, we weren't really coordinating, so yeah, so it's been we've had to do a little bit of housekeeping, so to speak, now that we're both back and paying attention. But yeah, so if anybody has any topic requests, if there's anything you'd like to see, please, of course, reach out to us. I know we've got some things not super close term, but we'll say medium term. We'll be talking about OpenShift 4.16 when it releases. We've got some other things in the pipeline around, I just said, OpenShift Lightspeed, observability. OpenShift virtualization is a topic that's coming up again. We talk about the reference implementation and some of the things that are there. There's one other thing that I'm forgetting. It'll pop up. Anyways, can you deep dive into physical networking on OpenStack? So Deepak, I don't know very little, or I know very little at this point about OpenStack. So I don't know that Jonny, if you feel comfortable talking about that either. So OpenShift, yes, absolutely. OpenStack, not so much. So OpenStack networking versus VMware vSwitches. Yeah. So what I would suggest is Deepak, send myself and or Jonny an email. You can see our email addresses here on screen. Sully, SULLY at redhat.com, or Jonny, JONNY at redhat.com. And we'll see if we can connect you with the right folks over there. That being said, I think it's going to depend whether you want OpenStack versus OpenShift virtualization. It'll depend very heavily on the type of workloads that you're doing and stuff like that. So our sort of default recommendation these days is OpenShift virtualization if you're looking at a VMware alternative. So we can certainly talk about that and go in depth. In fact, one of the very smart people on OpenShift virtualization is sitting right about 20 feet that way from me. So we will, yeah, but none of us know very much about OpenStack anymore. Years ago, I was an OpenStack person, but there's been about 10 releases since then, if not more. When I say 10 releases, I mean 10 releases in like Red Hat releases. Like it was probably OpenStack 9 or 10 was the last time. Red Hat OpenStack 9 or 10 was the last time I was involved in it.
Yeah, I think for me it was like 13.
Yeah, we're on 17 now or something like that. Anyways. So we will be back next week. We are planning on having a live stream. I know we've been a little bit inconsistent for the last few months, like we said, a hiatus, but back in the swing of things. Happy to talk about OpenShift, Deepak. So I was talking about OpenShift virtualization a moment ago. We can certainly spend a lot of time on OpenShift virtualization in that respect. So I've spent an alarming amount of time actually learning about the depths and the inner workings of OVN and OVS and all of those things and how they all work together with nm state. And I feel like I have enough to say that, or I know enough to say that I can scratch across the top of the surface. So we'll see if we can find some subject matter experts. Yeah, all good, Deepak. So we'll definitely add that to the list. That's a great one that we can talk about. I think coming out of Summit, I had a lot of conversations around OpenShift virtualization. So I am very happy to, I think we're very happy to spend some time on that and help answer questions. And typically, some of the OpenShift virtualization team watches the live streams. We'll see if we can get some of them to volunteer as well. With that being said, thank you so much, Diego, for joining today. This has been just a phenomenal demo. Really appreciate you taking through all of that. Great work.
Yeah, thanks for having me here today. It's always a pleasure.
Yeah, and you're welcome back anytime you'd like to come and show us anything.
Yeah, I will do.
So, to our audience, thank you again. We really appreciate you joining us today and spending the last hour and some change with us. As I've said a few times, please don't hesitate to reach out to us. Email, Slack are great ways to get a hold of us. There's also the OpenShift Reddit where you can tag Jonny or I. We have the same username in kind of all of these different places. So, yeah, just be on the lookout for us. Don't hesitate to reach out, and we're happy to help with things. And with that, Jonny, any last words from you?
I just thank you again, Diego. This was awesome. And I ditto what Andrew said about putting the big picture together, because I think when you're looking at it, a lot of us look at it in pieces, and so it's really hard to visualize how it all comes together. So thank you for putting that. Like, here's why you do it on the data center. Here's what you would do at the data center, and here's what you would do at the edge, and why. And thanks for you put an awesome story together. So thank you to you and Ben for jumping in and making sure that you kept us honest too. So thanks again.
Yeah, and I'm responding to Deepak's question instead of finding the place where I'm supposed to be clicking. How do you assign VLANs? Yeah, how do you assign VLANs with OpenShift networking? So the way that you do that, and actually, I think I can demo this. Can I demo this? I might actually be able to demo this. I have a cluster at the moment that I was doing some other things with. Let's see, share screen. This one. Let's expand it out a little bit. All right, so this is an OpenShift 4.15 cluster. Yep, 4.15 running OpenShift virtualization 4.15. So to create VLANs, you use a network attachment definition. So the way this works behind the scenes is I have nm state. And nm state is what I use to configure the underlying host networking. So for example, if I look at my worker node 2 here, I can see that I have a bunch of Ethernet interfaces that are created for various things, but the ones that I care about are these EMP 123 interfaces. These are the physical interfaces on my host. So what I've done in this particular instance is we have created an OVS bridge, creatively named OVSBR. And OVSBR is using EMP3S0 as the uplink. So in this instance, what I would want to do is I would want to create a network attachment definition. And I can create this secondary local network. And so I would create, we'll call it VLAN 123, and then I use OVS-BR here, and then I'm going to create VLAN 123. And then this is all that I need to do. So I use nm state to create the OVS bridge with EMP3S0 as the uplink port on it. So you can think of that as being, it is that OVS Open V switch. Is that what that stands for, John? I see you nodding.
Yep.
So with that uplink port, and then here I am creating my network attachment definition for my external VLAN access. Notice that this created in default. When I create network attachment definitions in the default namespace, they are accessible to all other namespaces. If I were to create it in a specific namespace, then it would only be available to that namespace. So now when I come up here to my virtual machines, I want to create one for, let's go to VM imported. So we'll create let's say from an instance type. And then actually I'm going to use a template here. So I'm going to create a RHEL 9 virtual machine. I'm going to customize it. And I want to customize it because I'm going to change my network. And I'll change my network over here to use, to use my VLAN 123. I do appreciate that it tags on a unique identifier there, and it chose Upset Donkey for this one, which is just an amazing name. I don't know how many times I've told the engineering team that created that generator that these things are amazing. And that's kind of all I need to do right now. When I create my virtual machine, it will attach to that particular, it will use that, Multis will use that network attachment definition to assign it. This is not actually going to connect to anything. There is no VLAN 123 in my lab. It was just an example. But yeah, that's how we do it. And so what happens is, so it's a single OVS underneath the covers. And then as the packets arrive, they are tagged with that VLAN. So if you're familiar with how we've done, like me, I'm an old school Linux admin, right? So it used to be we would create, take our interface, whether it's a standalone interface or a bond of interfaces, and then we would create VLAN interfaces on top of that. So I'd have bond 0.123 and bond 0.789. And those were my VLAN interfaces. And then I would create a bridge on top of that. And then I would connect my VMs into that bridge. And that's how they got tagged. There's a few things that I'll say were suboptimal about that. One of them is scalability. So it only scaled to a few dozen or maybe a few hundred VLAN interfaces before RHEL networking just said, nope, can't do anymore. And then also the bridges allowed communication between those nodes by default. So if I had two VMs on the same bridge, they could by default communicate, whereas with this type of setup, I can use things like network policy, technically it's multi-network policy in OpenShift, to control communication between those VMs, even as they're connecting out to that VLAN network directly. So there's a few other things somewhere amongst my many hundreds of tabs. I've got an article because our networking engineers shared this with me. But I've got an article about how it also avoids things like, you're probably failing to start because the VLAN 123 is not actually valid. Anyways, I'll stop sharing. Anyways, so I've got an article about why that's what are some of the security implications of that as well. So that way, so things like, because the VLAN, the packets are tagged with the VLAN, the moment they hit the switch, it avoids things like being able to overload the VLAN inside of there and kind of escape VLAN, stuff like that. Yep, use network. Oh, that was me. I responded to that. All right, Deepak, still don't hesitate to reach out if you have any questions, and we'll definitely put a meeting or a topic on our agenda to talk about OpenShift virtualization. I would also definitely recommend that you check out the OpenShift virtualization roadshow. So if I put the link in here, I think that's the right link. Let me double check it. So the virtualization roadshow is a thing that happens kind of all over the world. They have these scheduled. It's where you can go and sit down and get hands-on with OpenShift virtualization. And there's modules in there that walk through all different things associated with it. Step-by-step guide for deploying OpenShift virtualization on bare metal servers. You literally just install OpenShift on bare metal, and then you install the OpenShift virtualization operator. So there's been a number of, I guess it's been a while, hasn't it, Jonny? We should probably do a bare metal install thing. Maybe even a new, we talked about this a while ago, like the end of last year, talking about doing like a installer marathon of like, let's stream for 8 or 10 hours and see how many different install methods we can cover within that time period. But turns out we have real jobs to do.
That's weird.
I know. So, but yeah, it's just follow the process for deploying to bare metal. Note that you don't have to have a purely bare metal cluster. As long as you're doing a non-integrated cluster or platform none, you can deploy with a mixture of virtual and physical nodes. So for example, if you have, say you're running Red Hat virtualization today, you've got plenty of capacity in there, you deploy the control plane and some infrastructure nodes inside of there, maybe you've even got some other things, other applications running in there. So long as it's platform none, you can add a bare metal node inside of there, deploy the OpenShift virtualization operator, and then when you create VMs, they will get scheduled to that bare metal. The comparison of features, you'll have to talk to your account team for that. They'll help you with those types of things. Or come by with a roadshow. You'll be able to see it firsthand. So yeah. So Jonny, let's definitely build out an agenda for that. That'll probably be a longer one, a longer stream. Our Hope 9 hasn't been on today. He loves the longer streams. All right, y'all. Thank you for your time today. Greatly appreciate it. Don't hesitate to reach out. You see our email addresses there on screen. And we will see everyone next week. Same time, same place. Have a great rest of your week, y'all.
Yeah, thank you.